and then it's going to, right, we've got to go to my favorite block diagram. So this is my audio out. That's when it's talking to me. What's coming in is just the WH group, so it recognizes that. Right? So it's got some table lookup of all of these combinations of vowels and consonants. And it turns out English is a very easy language compared to Middle East or Indian. We don't have any kind of sounds in our language, luckily. So it can go through and do, it's not all that big of a table. When you think of all the sounds that we produce in the English language, it's not all that inclusive. So what do you think it does at that point? It's okay, I've detected a woo. There's some type of, I'll call it a table. This combination I'll call it text combos are.
Does it have some sort of function that would make that sound or like express that sound?
Yeah, so the next thing it'll do is say, what is my x of t? Right. So when you think about the sounds we make, it's a p, either I'm pushing air through or I'm vibrating my vocal cord. So I'm either going out with or I'm vibrating. So the English language is either I'm pushing air out or I'm vibrating. So it's either sort of like a constant on function or a sinusoidal or a step function, a pulse function. But my vocal cord is flapping. But, that's about the only thing we do in the English language. So it decides x of t. So it picks out if I have this, this, or constant. I think these are about the only three we need. So some type of pulse, noise, or constant.
Do we actually use noise though? I mean, like, does the human language actually have noise in it?
This is just like the signal source. So
okay.
my vocal cords can either be constricted and pulled and vibrating. That gives me more of like a pulse. This, let's see, how do we get? Yeah. So there, I don't remember. I don't have my textbook here with me when I was pulling this together for thinking about it. But yeah, there are sounds in the English language that the input sound is like noise. I just don't remember what it is. And then a constant. Okay, so it looks up that. Then what else is it going to look up? So it's got a signal source, that's x of t. What else is missing? The transfer function is just going to look up h of t. Oh, so this should have been, I'll call this the input to generate the sound, and then the h. Of t to generate that. Puts it together, and gets a sound. What? Sound. So that's all it's doing, but it's doing it really fast, right? It's got to do this, and then it's got to go over to the sound, and then the whoop, and it's got to do this. So and with each one of those, it's saying, okay, here's my signal source, here's my H of T, there's my output. Move on to the next one. Signal source, H of T, output. Signal source, output, boom. And that's what it's doing in rapid succession. And that's how you get from text to speech. So what you guys are doing is I Googled this, right? So I don't know if this is going to be a good transfer function. Is somewhere on this table, there's X of T. Right? And I said it was going to be a pulse function, right? And then some H of T, which God knows if that's right or not, right? And so it's going to generate one of these in this table. So that's what the function is. And that's why I get so excited when we talk about differential equations. And why we should all be excited, because it turns out the article that I sent you, maybe I should back up. How do you think these transfer functions are determined? How are these H of T's, all these H of T's determined? Anyone open up the other document I sent you yesterday? There's one, let me find the simplest model he's got here. He's got a model. He's got a model of sound production as a mass on a spring attached to a fixed mechanical thing. And can you write this as a differential? The motion of this mass, right? You can write a differential equation to describe that, right? I don't know. I'm always fascinated when, and then he's got a much more complicated model of 3 masses, 3 springs, and 1 coupling spring between 2 of the masses. You can certainly write a differential equation for that, and that's how you can populate your H of T's here, and then be able to come up with a text-to-speech. So on my text-to-speech,
On a Sunday, when I work 14 hours a day, 7 days a week, I get lucky.
I just love that. Let me see if I can do this quickly. So we all heard what she sounds like. Let me see how do So there's different profiles, right? When you do you guys use text-to-speech at all, or doing this? You can pick the person that's talking back to you, right? So in my application, there's Grace, and that's who's talking to me now. There's like an Edwin or something like that, or somebody. There's like 4 different profiles that you can hit, and if I was more capable with my smartphone, I could do that, and we could hear Edwin talk this back to me. It would be in a man's voice. When I work 14 hours a day, 7 days a week, I get lucky, right? What's different between those 2 implementations? Grace talking and Edwin talking.
Pitch is different.
What's that?
Pitch is different. So I guess like the frequency.
which it actually is the H and T